Picture this. It's the dead of winter, and you're stuck in a tiny wooden hut, surrounded by snow piled up higher than your roof, with temperatures dropping below -30 degrees F. You've got only a small fire to keep you warm, but the cold is relentless, seeping through walls, creeping under the door, turning your fingers numb and your breath visible with every exhale. Now imagine you're not living in a cozy cabin with central heating, but in the brutal Viking age over 1,000 years ago. No electricity, no modern insulation, just raw nature and survival smarts. So how on earth did the Vikings manage to keep their homes warm for 24 hours straight, surviving icy Scandinavian nights that could freeze your beard off and keep your teeth chattering for days? Believe it or not, one of their secret weapons wasn't a roaring fire but animal fat. Yes, you heard that right. This might be the strangest Viking survival trick you'll ever hear. Turning greasy, smelly animal fat into natural, 24-hour room heaters that could rival a modern 1,000-watt electric heater. It might sound bizarre, but back then, fat wasn't just food or candle fuel. It was the Viking version of a miracle material, their medieval hot water bottle, packed with insulating and slow-burning powers that made icy nights bearable. They learned to trap heat in layers of fat, creating a sort of primitive yet powerful heating system that kept their homes cozy without the ever-watchful eyes of smoky fires or big hearths. Think of it as nature's version of a high-tech space blanket, only made from the byproducts of their own hunts and butchery. Imagine walking into a Viking longhouse after a brutal day of raiding or fishing, and instead of stepping onto cold wooden floors or feeling the chill from wind slipping through cracks, you're greeted by warmth radiating from large slabs coated with thick animal fat, hanging strategically near your sleeping area. The fat absorbed the fire's heat and then slowly released it through the night, like a low-level oven keeping your toes toasty. This wasn't some accidental discovery. It was a calculated use of materials right at their disposal, turning what many would consider waste into life-saving heat. Before you dismiss it as some weird Viking superstition, here's the science behind it. Animal fat, primarily composed of triglycerides, has a relatively low thermal conductivity compared to bone or wood. This means it doesn't transfer heat quickly, so when heated, it acts like a thermal sponge, holding onto warmth and releasing it slowly over many hours. Scientists today call this phase change heat storage, commonly seen in modern materials used to stabilize temperatures in buildings, and even in some high-end camping gear. Vikings had no clue about triglycerides or phase changes, of course, but they perfected the art of using fat's slow burn properties to trap and dispense heat consistently. And check this out. Studies of Viking homes found that by applying layers of animal fat to wooden surfaces and walls, they could maintain internal temperatures about 15 to 20 degrees F warmer than the outside air when ambient temps were plunging below zero. That's like turning an icebox into a toaster oven. Pretty incredible when you think about it. All of this before the age of insulated drywall. But how exactly did they apply this fat to their homes? They didn't just smear it on willy-nilly. It was a careful, almost ritualistic process. First, they rendered the fat, cooked it down slowly to separate it from bits of meat and connective tissue, like a thick, rich grease. This rendering reduced moisture content drastically, making it more stable and less prone to spoil. Then, this purified fat was spread in thick layers, sometimes over 2 inches thick, onto the interior walls or stored in wooden containers positioned near the hearth or even under sleeping platforms. Here's a modern analogy. It's like covering your walls with a thick layer of bubble wrap, but instead of air trapped inside plastic pockets, you have a layer of dense fat that traps and gently emits heat all night long, while bubble wrap insulates by stopping air movement. Fat works by slowly releasing the heat it absorbed during the day from the fire or sun. The effect was a steady radiance that prevented chilling drafts from turning the longhouse into a freezer. Essentially, this fatty insulation was the Vikings' ancient version of a radiant room heater. The Vikings didn't just stop there with fat-coated walls. They also fashioned fat lamps or fat-fueled burning devices that served 2 purposes, light and heat, using hollowed-out bowls filled with animal fat and a twisted flax wick. These lamps burned cleaner and longer than traditional wood fires. Their flickering glow wasn't just cozy ambience. It gently warmed the room without flaring up smoke that could suffocate the small, enclosed space. Today, some specialty outdoor gear brands market fat-based lamps and torches that claim several hours of burn time and steady heat output, basically borrowing from this ancient technology. The slow, steady heat came with a safety bonus too. Fire was an ever-present danger in the wooden longhouses, especially during long, dark winters. Using these fat-based heating methods reduced the need for large, open flames that could quickly turn deadly if left unattended. In essence, it was like having a heater that stays on low, without the risk of setting your entire village ablaze. But even with this genius fat heating system, the Vikings still faced brutal cold. Snowstorms could block out the sun for days, and wind howled through forested fjords like a banshee. So they combined fat insulation with clever architecture. Houses built low, with walls 2 feet thick and roofs steeply pitched to shed snow. Plus, they raised sleeping platforms off the cold floors, sometimes wrapping themselves in thick animal pelts. Picture it like combining nature's version of Gore-Tex with a medieval version of bubble wrap and a primitive, slow-release heating pad all in one. Despite all these tricks, maintaining warmth in Scandinavian winters was a constant battle. Fat heaters bought them precious hours of comfort, but the Vikings also had to ration their fat carefully. Remember, fat was a valuable commodity. It's what kept them alive through nutrition, made candles that lit hearths, and served as currency in some cases. The fact they allocated so much fat to heating shows just how critical this innovation was. They understood the trade-off: less available food source, yet increased survival odds through smarter heat management. And here's another twist. Beyond heating their homes, Vikings used animal fat directly on their bodies as a kind of primitive thermal barrier. Hunters and warriors would rub tallow or rendered fat over their skin and clothes, a sort of natural waterproofing and windproofing that turned their garments into highly efficient insulators. It's sort of like using modern high-tech outdoor gear. But the real deal was smearing on greasy fat to lock out biting cold winds and repel moisture. This greasy shield wasn't just about keeping warm. It protected their skin from frostbite and chapping. Imagine waking up at dawn, plunging into icy water for fishing or raids, then easing back into a fetid, fat-coated layer that clung stubbornly to your clothes and skin. It sounds gross, but it was practical, even life-saving. In essence, the Vikings had their own version of thermal underwear made out of nature's most slippery survival oil. Now, we've only just started peeling back the layers of this fascinating Viking heating secret. From lighting and heating to insulation and personal protection, animal fat was woven into their survival strategies in ways that seem wild today but were wholly logical back then. And it didn't stop with warmth and dryness. In the next part, we'll dive into how Viking animal fat heaters influenced their daily rituals, social structures, and even trade routes, revealing an entire economy around this seemingly humble resource. But for now, picture those fierce Norse warriors, draped in fur and grease, gathered around dim fat lamps inside sturdy walls coated with layers of slow-burning fat, huddling close as icy winds screamed outside. That warmth wasn't just comfort, it was survival, family, legacy. And it all started with a simple, sticky, smelly secret most of us have long forgotten. Now, imagine you've survived the bitter cold with those glorious fat-coated walls and fat lamps. But how did the Vikings actually keep this fat from going rancid or melting away when the hearth was blazing all day? This was no small feat. Animal fat can spoil, turn sour, or drip off surfaces if not treated just right. That's where Viking ingenuity truly shines. They developed a process akin to curing meat, but for their fat heaters. After rendering, they mixed the fat with natural resins and soot, creating a thick, tar-like sealant that bonded the fat firmly to surfaces and protected it from moisture and air exposure. Think of it as an ancient sealant, almost like modern polyurethane, except fully organic and sourced from their own environment. This mixture turned the fat into a semi-solid layer that could hold heat steadily and resist dripping or rancidity for days, sometimes weeks. It's like turning your room's walls into giant slow cookers, filled with warm, protective grease that would have kept a Viking hamlet a toasty 20 degrees warmer than the frozen tundra outside. But keeping fat stable was only one part. Vikings also mastered the art of heat circulation within their homes. Unlike our homes, which use fans and ducts, These longhouses relied on strategic positioning of fat heaters and architecture that coaxed warmth through every corner. Walls coated in fat were often angled or textured, so that they caught the first rays of sun at dawn, charging their heat banks for hours. As night fell and the mercury plummeted to -30 degrees F or lower, the radiated warmth from these slow-burning fat layers created a gentle convection flow. Warmer air rising near the fat walls and cooler air sinking near the floor, but never becoming painfully cold. In effect, Vikings crafted their own microclimate inside these wooden shelters, successfully maintaining a comfortable internal environment in some of the harshest winters Europe has ever known. It might sound like magic, but to the Vikings, it was just smart engineering born from necessity, nature's own radiant heating system. And it didn't stop at keeping their own homes warm. Viking communities turned this fat technology into a kind of currency, traded extensively across seas and borders. Entire merchant ships were loaded with cured tallow bars and fat-impregnated wooden panels, prized possessions sent to colder settlements where firewood was scarce or less efficient. This trade boosted not only survival rates but social ties, as the sharing of warmth became a form of social capital. It's as if they were shipping barrels of fuel oil centuries before the industrial age. Archaeological digs show that certain Viking outposts specialized in fat rendering and fat-based goods, turning this greasy product into a cornerstone of their economy. So critical that some Norse laws even regulated its distribution to prevent shortages in winter. Fat wasn't just survival gear. It was a wealth-bestowing commodity, a lifeline connecting towns, fjords, and far-flung Viking colonies. Beyond their homes and trades, the use of animal fat seeped into Viking rituals and everyday life, affecting how they prepared for battle and festivals. Before raids, warriors would anoint themselves with thick layers of animal fat, not just for waterproofing and thermal protection, but as a form of mental armor, a greasy, shining cloak of fierce readiness. Imagine vast armies setting out under auroras, faces gleaming in flickering fat lamp light, the smell of rendered grease thick in the air. It was part of their identity, a symbol of strength and survival. Similarly, during feasts and sacred ceremonies, fat lamps illuminated longhouses with warm, golden light, literally fueling fellowship and shared storytelling during long winter nights. Fat was woven into the communal fabric of Viking life, symbolizing both the harshness of their environment and their thriving against it. Now, think about this whole system compared to our modern heating. A Viking longhouse equipped with fat heaters and lamps delivered a consistent output estimated to equal about 1,000 watts of heat, comparable to a small electric space heater, but without the flicker, the noise, or the risk of deadly carbon monoxide. Their slow-release, low-flame systems minimized smoke and accidents in tight, wooden huts. Plus, this method consumed far less wood, which was often in short supply after heavy winter storms. It was an eco-friendly, sustainable form of heating, powered by what the land provided and used with a careful, almost reverent balance. Today, we might spend hundreds on heating bills, but Vikings had found a model of energy efficiency over 1,000 years ago, built on the backbone of animal fat. Still, how did these fatty heating innovations influence Viking social life and hierarchy? Well, fat-based warmth wasn't shared equally. High-status families or chieftains often secured thick fat coatings and bigger fat lamps, effectively controlling who stayed warm and who endured more cold. This made fat not only a matter of survival, but also of power and influence. Wealth and access to fat meant better health, better sleep, and better readiness for battle or work. It's an early example of resource-based social stratification, where something as slippery and ordinary as animal fat subtly shaped Viking societies. On bitter nights, your survival could depend on which family you belong to and their fat reserves. It's a stark reminder that warmth has always been more than comfort, it's privilege. And as winter stretched on, even with fat-coated walls and fat lamps, Vikings battled condensation and moisture buildup, a pesky problem in poorly ventilated huts. They cleverly used fat as a moisture barrier too, rubbing it onto wooden beams and posts to repel dampness that could rot wood or give rise to mold. It's the ancient equivalent of waterproof paint, keeping structural elements dry and extending the life of their homes. This dual role of fat as both heater and protector made it an essential multi-tool for Viking survival. Imagine a single natural material that could warm you, waterproof your house, illuminate your nights, and shield your skin from frostbite, all found on the carcass of a freshly butchered animal. As we piece these clues together, a fascinating picture emerges. The Vikings' clever use of animal fat was more than survival ingenuity. It was a cultural keystone melding environment, technology, economy, and identity. Their houses weren't simply shelters but living organisms, exhaling faint scents of tallow and smoke, glowing dimly with fat lamps, radiating a subtle heat that spoke of human adaptability at its finest. In those ancient, shadowy halls, every greasy patch told a story of resilience, ingenuity, and the raw will to survive against brutal winters and rival clans. So the next time you sit by a warm fire or switch on a heater in the dead of winter, spare a thought for those Viking ancestors who, without electricity or insulation, turned animal waste into life-saving miracles. They harnessed the power locked inside fat in a dance of chemistry and survival, a primitive technology that rivaled modern heating systems and shaped their entire way of life. Every choice the Vikings made, from smearing tallow on walls to burning fat lamps, came from a fierce will to protect family, legacy, and the future. They transformed smelly, sticky fat into a warm embrace against the coldest nights the world has ever known, a testament to human creativity and relentless adaptation. Their story reminds us that survival is often about seeing potential in the overlooked and crafting ingenious solutions from nature's raw materials. In a way, those ancient, greasy longhouses were more than homes. They were triumphs of human spirit, where science met necessity and where heat born of animal fat meant life itself. And that, above all, is a legacy worth remembering.